The standard deviation is another way to measure the spread or dispersion of a dataset, and it should be roughly comparable to the interquartile range in many cases. Okay, the formula looks kind of horrible. We're going to focus on the version on the top left most of the time. That funny letter is a sigma, or a Greek S. And yeah, that's a big square root of a horrible sum of a different square divided by a number. It's rough, yeah? Let me go through an example with you. Okay, I'm still using that data set of those test scores I showed you. Right, so the first thing you need to do to find the standard deviation is to calculate the mean. Well, that's not so hard. You guys know how to do that. And there happen to be 32 of them, so it would be a lot of work. But you can actually use your calculator to do this, and I'll talk about that more in just a second. Anyway, the mean turns out to be 65.7188. And then what you're going to do is you're going to calculate, you see that part in the formula that says xi minus x bar? That's called a variation from the mean. And we're going to find a bunch of those. Okay? We take the first or smallest score in our list, 35, and subtract that minus the mean. And we get negative 30.7188. And that tells us that the score 35 is 30.7188 points below the mean. And then we do the next score, 37, and we find that it's 28.7188 points below the mean, etc., etc. We do all of the 32 scores on the list. Again, a lot of work, worth figuring out how to use your calc to do this, okay? But you could see how it could be done without a calc if you had to. Anyway, you end up at the end at 98, the highest score, minus 65.7188. And you see that that's a positive 32.2812, and that tells us, hey, we're 32.2812 points above the mean. All right, so these variations are telling us how far and in what direction each of our scores is separated from the mean. So they're called variations. Now what we're looking for is a way to characterize the average variation. Right? But if we just average all of our variations, you can see that with positives and negatives, they're going to kind of cancel each other out, and we're going to get a number that's really close to 0. Right? But we don't want to do that, because positive variations that are large and negative variations that are large both mean that there are values that are far from the mean. So we need a trick, a way to figure out how to get past that. And you could use absolute value, but that turns out to be kind of difficult to use in computing situations, and so people have come up with a different trick. And that is, okay, we're gonna square each of the variations, because as we know, if we square a number, it becomes positive no matter how negative or positive it was to begin with. So we're gonna square them all, and then we're gonna add them up and divide by n. Okay, so we're taking like the average of the square of the variations. Right, so once we have the average of the square of the variations, that's called the variance. And for reasons that are very difficult to explain, if you're finding the standard deviation or the variance of a sample, that is a limited subset of a population, instead of a population, then instead of dividing by n, you divide by n minus 1. I looked several sources up to explain that, and none of them are very satisfying, and they're all very boring and complicated. Anyway, depending on whether you're finding the population standard deviation or the sample standard deviation, you divide by n or n minus 1. So just watch out for that. And the sample standard deviation is called S, not sigma. Alright, so you find the mean, you find all of the variations, you square each of them, add those up, divide by n in this case, since we do know the whole population, and finally, to turn the variance into the standard deviation, we take the square root. This must be like the longest that any one screen has been up in my YouTube history. Anyway, so we got the square root, and in my case, the answer was 15.57. Alright, so go back and compare that to the IQR, and that's pretty close. Alright, so the standard deviation is a very commonly used way to describe the spread of a data set. I know I used it a lot when I was a scientist, so you'll see it if you do anything related to science or any kind of data, really. In your calculator, if you have a stat button, press it. Along the top there should be a menu of things. Among them should be calc. Go there and you should see things like sigma and S and the mean, all sorts of good things that you can use as a shortcut. So I would highly encourage you to learn how to do that. Each calculator is a little bit different, but I think that should get most of you most of the way there. There are situations in which the measures of spread that we've talked about are a bit deceptive or a bit misleading, especially standard deviation. What if you had a distribution like this? It has two distinct peaks that are widely separated. This is known as a bimodal distribution. And this sometimes happens with grades. Let's say there was one group that didn't study, and they had an average of around 20, and another group that studied a lot, and they got an average of around 90. Okay, the mean would be, I don't know, somewhere around 60. Well, that doesn't really tell you anything, because nobody got 60. And the standard deviation might be something like 35, but what the heck does that tell you? I mean, really what you would want to do to describe this data set would be to say, look, it's a bimodal distribution. It has two populations, one with a mean of 20, one with a mean of 90, and then you could find the individual standard deviations of each of those. Here's your homework for the week. Page 862, 1 to 33 odd, 39 to 47 odd, and 51 to 57 odd. Good luck, guys.